Anybody have any ideas? What could we have done?
I came up with this question.
Okay.
The answer is 1.4.
Okay, so let's look at that. How did you get that?
So, I made the little box thing, and then I put 33.8 inside, and 32.5 could only go into 33.8 once, and then that gave me 1, and then I made another 0, like you said, and I brought it down. Yeah, I brought it down.
Okay, so then what was left over? 13, is that right?
Yes, ma'am.
Okay, so then there's my decimal, there's my 0. Okay, so right here, can 325 go into 130? No, so that's going to be a 0 here. Then I add a 0 and bring it down.
If you're writing, this screen is frozen.
Can you not see what I'm writing?
No, ma'am. I think your screen is frozen.
Oh, okay. Hold on. Okay, can you see it now?
Yes, ma'am.
Okay. Yeah, so remember we have to take the 325 and we have to make it a whole number. So, or 32.5. So we make it, it becomes 325. That means we have to move this one place to make it 338. So what I was saying is you were right so far. So 338 divided by 325 is 1. But what happens is I get 13 left over. If I add a 0 and bring it down, 325 doesn't go into 130. So that 0 goes here at the top. So then I add another 0 and bring it down. So then 325 goes in there 4 times. So you were close by saying 1.4, but it's really 1.04. Right? So 33.8, if I do it on a calculator, see, it gives me the same answer. So the answer should be 1 4/100. Okay?
What do we put for the points earned today?
So it's either 1 or 0. You either get it right or not.
Oh, okay. Gotcha.
Okay. All right. So if you will put that wherever you need to remember where it's at, and open your books to page 261. 261. All right, is everybody good? All right, so we are going to identify and generate equivalent algebraic expressions. So now we're going to learn how to substitute information in and see if one equation is equivalent to another. Okay? So your objective today is to use the properties of operations to determine if two equations are equivalent and to generate equivalent algebraic expressions. All right, so we're going to use what we learned on Thursday and Friday, and we're still going to substitute information in. Okay, so on the first one, it tells me that x is 6. So I'm going to substitute 6 where x is. So I get 6 squared minus 5 times 6. Okay, and then I'm going to do the same thing over here. So I'm going to substitute in 6. So I'm going to get 6. Remember that means times because it's next to parentheses. 6 minus 5. And then I'm going to follow the steps that each one tells me to do. So I need to evaluate the exponent. So what does that mean? Evaluate the exponent. And what would I have from that exponent? Anybody have any ideas? So 6 to the second power, 36. Yes, thank you, Kylie. So that means 6 times 6. Then we're going to bring down the 6. So then 5 times 6 is?
30.
Yep. So then 36 minus 30 is what?
6.
6. All right. So we are going to see, is this equation and this equation equivalent when we substitute in the same number? All right. So orders of operations, we need to do the parentheses first. So 6 minus 5 is what?
1.
1. And then bring down the 6. And then 6 times 1 is?
6.
Yep. So I get 6 here. I get 6 here. So are they equivalent?
They do have the same value in x.
They do. So the expressions do have the same value when x is 6. All right, so let's look at the next one. It says the hexagon shown, Linda says the perimeter can be found using the expression 4 times s divided by 2 plus 2s. Right? So we have 1, 2, 3, 4, and then s and s. So I can see that. But David says that he can use the expression 4s to find the perimeter. Do the expressions have the same value when s is 8? So we're going to substitute in 8. So 8 divided by 2 plus 2 times 8. And then this one would just be 4 times 8. All right, so divide first because that's orders of operation. So what's 8 divided by 2?
4.
4. And then 2 times 8
is 16, and 4 times 4 is 16.
Yep, so 16 plus 16 is?
32.
Yep. All right, then come over here. What's 4 times 8?
32.
So are they equivalent?
Yes, ma'am.
Yep. So the expressions do have the same value when s is 8. All right. So look at the turn and talk. It says, how could you compare the expressions in part A using the distributive property? So, x minus 5, right? And then my original equation was x squared minus 5x. All right, so if you remember when we distribute, that means I have to multiply whatever is on the outside by everything inside. So this is where my first period class got mixed up. So x times x plus negative 5 times x. Anytime I multiply a variable, x times x, I get x squared. So x squared plus negative 5x. which is also equivalent to saying x squared minus 5x. So do I get, by using the distributive property, the same original problem that we started with?
Yes, ma'am.
Yep, I do.
But why is
So,
it negative 5?
because it started out with a negative here.
Oh, that's a negative 5?
Well, remember I said minuses and negatives mean the same thing. Okay? So, if I have something that says negative 5, and if I'm doing, let's say, 1 minus 5, it's still a negative, because even though this is a 7th grade standard, I can change this to addition, and I can change that minus 5 to its opposite, which is negative. So that's why it's the same thing. Okay? All right. Any questions? All right, moving on. So properties. So I know that you guys have talked about the commutative and the associative property before, but we are going to use those to manipulate our expressions around so we can combine like terms. So it says equivalent expressions are expressions that have the same value for all possible variables of the values of the variable. Of course, you can't check every possible value. Fortunately, there's an easier way to show that expressions are equivalent. You can use the properties of operations. If you can apply the properties to one expression to get the other, then the two expressions are equivalent. So that's kind of what we just did, right? We applied the distributive property down here, and we ended up getting the first equation that we had. So we applied a property. So our properties, again, are the commutative, and that's addition and multiplication, associative, addition and multiplication, and distributive. The thing to remember about the commutative and the associative. So the commutative means that we rearrange the letters or the numbers. The associative, I don't rearrange the letters or the numbers. The only thing that I rearranged are the parentheses. Okay? So that's important to remember.
Miss Lavelle,
Yes.
what does it mean by the grouping of the numbers?
So see how I'm grouping A plus B here?
Mm-hmm.
And then over here I'm grouping B plus C.
Right.
So I changed the grouping. I didn't rearrange the A plus B plus C. I changed the grouping.
Well, for multiplication, I don't understand that. Because if you were doing 5 times 7 times 8, it would be a different product if you were to multiply 7 by 8 first, wouldn't it?
Nope. So if I do 5, let's say like you said it, 5 times 7 times 8, right? And then if I rearrange it and do 5 times 7 times 8, I get 35 here, right?
Right.
And 35 times 8, that would be 40. 32 would be 360, right?
Right.
Okay, I can do this one first, which 7 times 8 is 56, is that right?
Because 7 times 7 is 47, so yeah.
Okay, and then times 5, so I get 30, carry the 3, yeah, something's not right, hold on. 35, so 35 times 8. Oh, I didn't do it right. What's 3 times 8? It's not 32. It's 20.
34.
20. Isn't it 24?
3 times 8 is
24.
Oh, 24.
Yeah, we both did that one wrong, didn't we? 3 times 8 is 24 plus 4 is 280. Yes. So then, yeah, now they're equal because I didn't do my multiplication right. So yes, so what they're trying to tell you is no matter what the order is, you're going to get the same answer.
I thought it was different answers for that.
Nope.
Multiplication.
Nope. Okay, so let's look at an example. So we're going to identify the properties used, and we're going to see, is this equation equivalent to this once I use my properties? Okay? All right, so the first property. So how did we get from here to here? So what did I do to get rid of these parentheses?
You do, so now it's 8B, so...
Right, so I distributed, right?
It's 4.
So I did 4 times A is 4A.
Right.
And then I said 4 times 2B is 8B. So this would be the distributive property. Okay?
Okay.
So from there, what am I doing? What did they do? 4A is here and 4A is here, but now they're next to each other. So what property is that?
The commutative property.
Yeah, commutative.
Why are they all such big words?
I don't know. All right, so what do you notice about the next ones? Because they didn't really give us an example of that. But it looks like something up here. It's either that one or this one. Okay? So this is what so when they have something in common, so even though the 4s are in common, the A's are also in common. So what they do is they factor the common out. And what we call that is kind of like the reverse of the distributive property. So when you factor something out, we're reversing the distributive property.
Okay.
So that's what property goes there, is distributive. Okay? So now I can just add the 4 and the 4, which is
makes
8. So that's why it says add the inside parentheses. All right, so now we're going to factor again because I have an 8 here and an 8 here.
So that's distributive property again.
Yep. So what I factor goes on the outside of the parentheses, and then what is left is what I didn't have. So 8 goes on the outside, and then A plus B, and that is the distributive property again.
And then it would be whatever A plus B is, and then 8 times that.
Right. If we were going to substitute numbers in, yep. Whatever those numbers we substitute in would be A plus that number, and then times 8. Yeah. All right. So did we get this answer up here?
Yes, ma'am.
Yep. So that means it is equivalent. All right. What about B? Is 8x plus 5y equivalent to 3x? All right, so once again, what's in common?
The x and y.
Yep, so they're going to factor that out.
So distributive property.
Yep, so that would be the distributive property.
Why is distributive property like the most used word?
I don't know. It just happens to be in this lesson. So that means what's left is 8 and the 5.
Plus 5 x.
So 8 plus 5 is?
13.
Yep. What did it say it was going to be?
3.
Yep. So are they equivalent? Yep, they are not equivalent. Are not equivalent. All right. Moving on to number 3. So a triangle is drawn so that starting from the shortest side, each side is 1 unit longer. So as you can see, S and then S plus 1 plus S plus 2. So we are going to do something and we're going to combine like terms. So like terms are terms with the same variable raised to the same exponent. So what that means is if I have x and I have x squared, these are considered to be not alike. Because of this, they are not the same. But x and x are the same because I don't have a little exponent on either one of those. Okay? So 3x and 2x are the same. But if I had 3x squared and 2x, then those are not the same. Okay? So that's what it means by the x has to be raised to the same exponent. So this one has a squared, this one does not. They're not the same. Okay? Also notice I cannot add an exponent, a variable with a letter. This and this, not the same. Because the 3 doesn't have an x. Okay? All right, so let's look at that. So we started out with s plus 1 plus s plus 2. Then we moved here. So what do you notice they did? What did they move around?
They moved the s from the s plus 1 to s plus s.
Right.
Which would be commutative property.
Okay, is it commutative? Did I rearrange or did I rearrange my parentheses?
Oh, it's associative.
Yeah, because it's still s plus s, right? But now I just group them using my parentheses. So that is the associative. Okay? So now what did we do? We went from here to here. This is the same. What happened here?
You rearrange the... Well, that one would be commutative property because you didn't change the actual things in the parentheses. You just...
Correct. Correct. I moved the parentheses around, so it is commutative. Okay? All right, so now I've got s plus s plus s plus 2 plus 1.
Now it's s plus s plus s and then plus 2 plus 1.
Yep. So what property is that?
Associative.
Yep. That's associative. All right, so what they did, so even though you can't see it, there is really a 1 in front of each s. So there's really 1s, 1s, 1s. So what they did was they factored out an s and then just put the 1s in the parentheses. So we factored something out, right?
So it would be 3s plus 3.
Yep, so we use the distributive property, right? Because when we factor, it's the reverse of the distributed. So it's 3s plus 3. That is correct. That is correct. That's it. Can I add those together? Right. This does not have a variable, so this is your answer. 3s plus 3. All right, what about number 4?
This one seems crazy.
R is 6w plus 3z plus 4w plus 7z equivalent to 8 times 4w plus z. Okay, so what are like terms? So in the expression 6W, 3Z, 4W, and 7Z, the terms 6W and 4W are what we call what?
Variables? Or like terms?
Like terms, right? Because they both have a W. 6W, 4W. So these are like terms. All right, so what are my other like terms in here? So we've used this and we've used this.
And the terms.
Hold on one second. So, yep, so what else? 3Z and what?
And the terms 3Z and 7Z are like terms.
Yep. I'm coming. Sorry. All right, so yes, that is correct. So 3Z and 7Z. And I put little lines through my Z so they look like Z's and not 2's. Are considered to be like terms. All right. Bye, guys. All right, so what property? So I went from here to here. So what property am I using?
Commutative.
Yep, because I rearranged. Okay, so now what did they do? 6 plus 4, what are we missing?
The W's, so
Yep.
that would be distributive.
So that would be distributive, right? All right, and then here they took out a Z, so what goes here?
3 plus 7.
Yep. All right, so add inside parentheses, so 6 plus 4 is?
12, or no, 10.
Yep, and 3 plus 7?
Is also 10.
Yep.
Then 10 times W plus Z.
Yep.
Which is the,
I factored, right?
distributive.
So that's distributive. All right, so is this equivalent to this? Did we get that same answer?
No, ma'am.
No, we did not. We got 10 instead of 8. So it is not equivalent. All right, how can I show that 8 times x plus y plus x plus y is equivalent to 16xy? So what property?
Would it be distributive?
Yeah, because I'm distributing the 8. So 8 times xy plus 8 times xy. So that gives me 8xy plus 8xy.
Okay.
So that gives me...
Make 8 parentheses.
Well, if I factor, I'm back to where I was, right?
Right.
So now we're just adding them.
But 8 equals 16.
Uh-huh.
So you could just do 16xy.
Yep. Exactly. The other thing I could have done is I could have added my parentheses first. So xy plus xy is 2xy. And then we know that 8 times 2 is 16, right? So that's the other thing we could have done. All right. So let's look at the check understanding, because my first period class had a little bit of issue with the first one. Okay? So if we're going from here to here, right, to see if they are equivalent, what did they factor out?
What did they factor out?
Yes, if this is my equation, 8x plus 4y, what did they take out? I just put it in the box for you.
4.
Mm-hmm. Because isn't that what is in common between 8 and 4?
Right.
My variables aren't in common, but the number 4, because I can divide 8 by 4. So we take out the 4, and when I do that, so basically, guys, when you're factoring something, you're really just dividing. So I'm saying 8 divided by 4 is 2, so that leaves me with 2x, and 4 divided by 4 leaves me with y. So is this equivalent to this?
Yeah.
It is?
Y would equal 1.
But we don't know that y equals 1.
So it's not equivalent?
Yeah, y could be 10. It could be 5,000, right?
Right.
So this is not equivalent. Okay, so what about number 2? It's distributive, right? Anytime there's a number outside the parentheses, I distribute. So 3 times k is 3k, and 3 times 3 is 9. So is that equivalent to this?
Yes, ma'am.
Yep. Equivalent. All right, so we have about 10 minutes in class, okay? If you wanted to get a jump start on your own, we are going to work on the on your own tomorrow. It is not a single lesson for today, okay? So your on your own questions are going to be 3 through 7, 8, 10, 12, 14 through 21, 22, 25, 26, and 30. So it is a long on your own, so that's why I've shortened it. Okay, so those are the problems you're going to work on. I am here today. Remember, I am here tomorrow. Okay, so if you want to get a jump start on it, that is what we're working on.